Section 1.4, Systems of Linear Equations in Three Variables. The objective in this section is to solve system of linear equations in three variables algebraically, meaning without using a calculator. And then next, the second objective is to solve applications involving systems of equations. So a system of linear equations in three variables consists of a system that has three equations with the three equations consisting of the variables x, y, and z. So typically your equations will look like ax plus by plus cz equals to d, where a, b, c, and d are going to be real numbers. You'll have three of them in the system, and typically speaking, the solution is going to be an ordered triplet, meaning three numbers, x, y, z, that you'll have to find for the problem, and these x, y, z will satisfy all the equations in your system, meaning they make every equation true. Now, to solve a system of three linear equations with three variables, you need to get it into what's called an upper triangular form, which looks like this. And to accomplish this, you're going to follow the following three steps. You can interchange any two equations, you can multiply an equation by a non-zero constant, or add a non-zero multiple of one equation to another. This is basically the elimination method, just for three equations instead of two equations. Now, the solution to the system is going to be x, y, and z. You're responsible to get that. But once you have the solution x, y, and z, how do you know if you got the right numbers or not? This is what we will try to do in the first problem. So somebody suggests to us that the order triplet 3, -2, 1 is a solution of the system on the right-hand side. And the question is this true or not? So typically, this is going to be the last step of your problem. Once you've solved the problem and you want to confirm that this is the correct solution to the system, you'll have to check it by plugging the numbers x, y, and z into all the equations to see if all the equations are satisfied. So we'll start by checking equation number 1, which is x plus y plus z equals to 2. And we're told that x is 3, y is -2, and z is 1. So let's plug those numbers in and see if we get a true statement. So 3 added to the y, which is -2, added to the z, which is 1. Is that in fact equal to 2? So remember, x is 3, y is -2, and z is 1. And we're given that order triplet, but in the future, you have to find the order triplet yourself. So 3 with -2 and 1, that's going to be 4 minus 2, which is 2. And is it true that 2 equals to 2? This is in fact a true statement. So far we are happy. The order triplet works for the first equation. So we cannot stop. We have to check the second equation and the third one as well. So let's go ahead and check equation number 2, which is 6x minus 4y plus 5z equals to 31. So plugging in the x and the y and the z, is it true that the number will be 31? So 6 times 3 is 18, -4 times -3 is going to be +8, and 5 times 1 is just 5. Is that really in reality the same as 31? And you can confirm that it is in fact equal to itself. 31 on one side and 31 on the other side, so that means that we have another true statement. Again, we are not completely done because we still have the third equation. The order triplet must satisfy all the equations to be considered a solution. So now, off to the third equation, which is 5x plus 2y plus 2z equals to 13. And as you can see, we get 13 on the left, and it's already got a 13 on the right. So it is in fact true that for the x value 3, the y value -2, and the z value, which is 1, the third equation is also satisfied. Since we now have a true statement on the first equation, second equation, and third equation, we can finally say that the order triplet that we were provided with is in fact a solution to the system. And in this case, I wrote that 3, -2, 1 is a solution of the given system because there could be more than one solution. That's why I'm using a solution versus the solution of the given system. Okay, so this is how you confirm your answer is correct once you have an answer, but now how do you get the order triplet? As I said earlier, we can use any of the three options that are listed here on this page: interchange two equations, multiply an equation by a non-zero constant, or add a non-zero multiple of one equation to another. That might be hard to do in practice and it might be confusing, so I'm writing the procedure again over here with a little bit more detail so that you can do this on your own. So pause the video here for a second if you want to write this down, but it's a good idea to know the procedure, and we'll go ahead and explain the procedure on the next page with a few different examples. Okay, so example 2 is basically asking us to solve each system. They're giving us multiple systems, and we're expected to find x, y, and z. Typically speaking, we're going to label each one of these equations as equation 1, equation 2, and equation 3, and we will follow the steps that we described in the procedure on the previous page to get x, y, and z. Now, if we pay attention to the equation number 3, we already can tell that negative 6z is equal to negative 30, which is easy to determine 5 from this, right? So if I divide negative 30 by negative 6, I get that z should be equal to the value 5. So this is a freebie. And why is this happening? This is happening because the system that we were provided with is already in that triangular form that we like. The third equation has only one variable, the middle equation has two variables, and the first equation has three variables. So since we started off by finding z, we're going to have to find either x or y next. But I remember that equation number 2 has two variables, and they are negative 2y plus z equals to 4, and I just determined that z itself is 5, so I'll go ahead and plug in 5 there and see what I get for the value of y. So z is 5. I need to isolate the letter y, so I'm going to remove the 5 and put it on the other side by subtracting 5. 4 minus 5 will be negative 1. And now I get that y should be negative 1 over negative 2, which is the same thing as 1/2. And so there we go. We have the second letter or the second variable that we need to find. It remains to find what x is, and for that we'll need another equation that has the letters x and y, or x and z, or x, y, and z. But we can see that equation 1 has all three variables. Equation 1 is x plus 4y minus 3z equals to negative 13. And so let's go ahead and plug all the numbers that we got for y and z. So far we know that y is 1/2, and we know that z is 5, as we previously found. So if I plug 5 for z and 1/2 for the y, this should be straightforward to solve, and I can isolate the x and determine what the x value will be for this problem. So first of all, 4 times half is going to be 2, 3 times 5 is 15, and I'm supposed to get negative 13 on the other side. So solving this for x, what is x supposed to be? So 2 minus 15 is going to be negative 13, and when I move it to the other side, it becomes positive 13. So x is expected to be 0. So what is my order triplet? What is the solution of this problem? The solution is the order triplet x, y, and z, where x is 0, y is 1/2, and z is 5. And notice how we write the numbers in alphabetical orders with x first and y second, and at the end, the z. Okay, let's continue with this example. Now we have x minus 2y plus 3z equal to 9, which we will call equation 1. Then we have negative x plus 3y minus z equal to negative 6, which we'll call equation number 2. And finally, 2x minus 5y plus 5z, which we'll call equation number 3. And again, the point is to eliminate one of the variables from two equations, then pick two different equations and eliminate the same variable. So in my opinion, if we take equation 1 and equation 2, it's clear that we can directly eliminate the x. So let's go ahead and write those down. Equation 1 followed by equation 2. And we will add them up and see what happens. So adding the equations up together, we can see that the term with x will disappear because x minus x will become 0. Then we'll have negative 2y plus 3y, which gives us just simply y. 3z minus z will be a positive 2z, and 9 minus 6 will be 3. We will call this equation number 4, and we will leave it for a few minutes, and we'll come back to it in just a moment. As you can see, though, this equation has no letter x, so we will need two different equations other than the combo 1 and 2 from the original problem, and we will try to eliminate the x as well. It seems like if we pick equation 2 along with equation 3, for example, we can multiply the second equation by 2, then add up the two things, and that will eliminate the letter x as well. So let's go ahead and do that. Let's take equation number 2 along with equation number 3. We will multiply equation number 2 by the number 2, and we will add up the two equations, and hopefully we will have an equation that has no letter x in it. Okay, so multiplying equation number 2 by the number 2, we get negative 2x plus 6y minus 2z equals to negative 12. And we're leaving equation number 3 alone. And let's combine the two equations. And that should result in 2x and negative 2x canceling out. Next, we will have to worry about the 6y minus the 5y. That's just simply going to be y. Negative 2z plus 5z will be a 3z. And finally, 17 and 12, negative 12, that will be just simply 5. We will call this equation number 5. And again, we will leave it for a second, and we'll come back to it in a moment. But what's important to notice is that this equation has no letter x. So what we want to do next is write the equations 4 and 5 together in one spot and start by, again, using the elimination method or the substitution method to try to solve this new system that we've created that has only two variables. So equation number 4 and equation number 5 are now together. And it seems like if we just subtract the two, then we will end up eliminating one of the variables. So let's go ahead and do that carefully. So y minus a y is going to be 0. I'm not going to write that down. It's not required. 2z minus 3z will be a negative z. And then finally, 3 minus 5 will be a negative 2. This implies that z should be just simply the value number 2. And that's our first missing variable. So now it's straightforward to work backwards. We can use one of equations number 4 or number 5 and plug 2 for z in it to get the y. I'm going to use equation number 4, so I'm going to write, but wait a second, I remember that equation 4 has the letters or the variables y plus 2z, and they're supposed to be equal to 3. But I just discovered that z is 2, so that means y plus 2 times 2 should be equal to 3 because z itself is now 2. And so how much is y going to be? So y plus 4 has to be 3, which implies that y has to be negative 1. And that's our second missing variable. So we just need to find x at this point in time, and we'll be completely done with the problem. To find x, we can use any of the original equations in the original problem. So we've got 3 of them. Pick whichever one seems easiest to you. I think the easiest one will be the first one. It doesn't have too many negative numbers. It doesn't have too many big numbers, but maybe you prefer another one. It's up to you. I'm going to choose equation number 1 to finish the problem. So I'm going to write down equation number 1 again, and I remember that equation number 1 is x minus 2y plus 3z equals to 9. And so how much is x? X minus 2y, but y is negative 1, plus 3z, but z is 2, is supposed to be 9. So this means x plus 2 plus 6 has to be 9. And so x must be, let's see, 6 plus 2 is going to be 8. Move it across, it becomes negative 8. and 9 minus 8 will be just simply 1. And that is the end because we now have the variable x, y, and z. So what is the solution of this question or this problem, this part of the problem? It's the ordered pair x, or the ordered triplet x, y, z, which consists of the numbers 1, -1, and 2. So remember, it's got to be in alphabetical order where x is first, the y is second, and the z is last. And if you want to confirm if you did this correctly or not, you can take those numbers and plug them all into the original problem in the 3 equations and see that they make each equation true. On the next page, there's some extra practice problems that you can try out. I'm not going to solve all of them here in this video because then the video will be way too long. However, I'm giving you the final answer, and in case you don't know how to get these answers, then talk to me in office hours and we will address the issue. But the top one is going to have solution -2, 3, 1. In example 3, the first one, the solution is 1, 4, -2. For part 2, the solution is 2, -1, 3. And finally, part 3 has a solution 2, 0, 1. It will be a good idea for you to practice doing some of these the long way, but in the future videos that we will have, we will show you how to find these answers using the calculator so you don't have to do all this ton of work. But it's a good idea to know how to do it the algebraic way in case your battery calculator dies or whatever, or you forget your calculator on an exam, or maybe you don't even have a calculator and you would like to get the solution of these problems. At this point in time, what I'd like to do is move on to a simple application problem where the problem is a word problem that will be translated into 3 equations with 3 unknowns, and we'll go ahead and solve this together. Okay, so let's read example number 4 together and set it up, then solve it. A student takes out a total of $5,000 in 3 loans. 1 from the bank, 1 from a grandparent, and 1 through the school. The loan from the bank is $200 more than the combined total of the other 2 loans, and the loan from the grandparent is twice the amount of the one through the school. Find the amount of each loan. So for these types of problems where you have a word problem, the first step is going to be to get some variables in the mix, label them, and assign each one of them an amount. So in this case, I'm going to let X be the dollar amount that the student got in loan from the bank, and Y will be the dollar amount that the student took out from the grandparent, and finally Z will be the dollar amount that he took through the school. So now that we have the variables, we will save them and we will use them to translate each one of the equations that we were given, or each one of the sentences. So first things first, we know that the student took out a total of $5,000 in the 3 loans. So that means that X and Y and Z should add up to $5,000. So that's what we get from the very first sentence in this example. Now, in the second sentence, we're told that the loan from the bank is $200 more than the total of the other 2 loans. So the bank loan is what we're calling X in this case. That is, the word is in math means equal. It's $200 more than the combined total of the other 2 amounts. The other 2 amounts are basically the other 2 variables, Y and Z, but X is 200 more than this. So we're going to take this number, or whatever this quantity is, we're going to add 200 to it. So that is the translation of the second sentence that we have in this problem. Then finally, we are told that the loan from the grandparents, remember this is what we're calling Y, we're told that the loan from the grandparent is twice the amount of the loan through the school. The loan through the school was called Z, and twice as much just means multiply it by 2. So the value that he got or she got from the parent is twice the value that they got from the school. So that's the translation of the third sentence of this problem. And so now we have our three equations, and we're expected to find the values of x, y, and z. The first thing I'd like to do here is rearrange the equations so that we have a clearer picture of what's going on. So we know that x plus y plus z is 5,000. I'm going to move the y and the z on the second equation so that they are together with the x term. So that's x minus y minus z will be 200. And finally, the third equation will have y minus 2z equals to, well, when we move the 2z across, there's nothing left there, so that's just going to be 0. So this is going to be called equation 1 and equation 2, and finally equation 3. And what we have to do now is work our way backwards to find x, y, and z somehow. As with any system of three equations with three unknowns, there are many different ways of approaching this problem and solving for x, y, and z. But it seems like I have an equation that already misses the letter x. So if I can create another equation that doesn't have the letter x, then I can use that fourth equation with this one, equation 3, to get y and z quickly. And it seems like if we just take the first equation and the second equation and subtract them from each other, the letter x should disappear. So that's what I'm going to do. I'm going to take equation 1 and equation 2 and basically subtract the two from one another, and that will eliminate the x variable. So x plus y plus z is 5,000, and x minus y minus z is 200. And if we subtract them, x minus x will be 0, y minus a negative y will be 2y's, z minus a negative z will be a 2z, and then finally 5,000 minus 200 will be 4,800. And so this is going to be called equation 4. And as before, we'll leave it for a few seconds and we'll come back to it in a moment. But what's important to notice is that it doesn't have the letter x. So if I can find another equation or create another equation myself that doesn't have the letter x, then I'm basically good to go. And thankfully, in this problem, the third equation already came without the letter x. So what I'll do is I'll put equation 3 and equation 4 together in one place, and I'll go ahead and eliminate some variable from them to get the other variable for free. So equation 3 and equation 4, we can eliminate very quickly the letter z if we just simply add those equations up with each other, because one of them already has negative 2z, the other one already has positive 2z. So y added to 2y is going to be 3y, negative 2z added to 2z will be 0, and 0 plus 4,800 will be just simply 4,800. So y will be 4,800 divided by 3, which is 1,600. And so there we have it. One of the three missing values is now found. Now, since we know what y is, we can easily retrace our steps backwards and find what x and z are. For example, the green equation here, y is equal to 2z, can allow me to find z very quickly because I know what y is. But wait a second, we remember that y is 2z, and we just discovered that y is 1600. So how much is z? Well, z must be 800 because 2 of it will be 1,600. And finally, we need x. We know in the middle equation that x is equal to y plus z plus 200. So let's go ahead and use that, but we know that x is y plus z plus 200. And we just discovered that y is 1,600, z is 800, and we have a 200 at the end. So what is x going to be? X is going to be the sum of 1,600 and 800 and 200, which is 2,600. And remember, all these are dollar amounts. And you can confirm that if you added the values x, y, and z with each other, the total will be 5,000, just like we heard the student took out $5,000 in loans. So in summary, the X represents the dollar amount that the student took out from the bank, which in this case is 2,600. Y is the amount that the student borrowed from their grandparents, which is $1,600. And finally, Z represents the dollar amount of the loan that the student took from the school, and in this case, it's 800. So the solution is 2,600 followed by 1,600 followed by 800. Okay, example 5 is another word problem, so I'll go ahead and set it up, but I'll give you a chance to solve this one. I won't go through the whole setup and solving. I'll just set it up and I'll give you the final answer. So reading this example 5, it says a total of 2,500 tickets to a soccer match were sold. Prices were $2 for the children, $3 for the seniors, and $5 for the general admission. We are told that twice as many tickets were sold to seniors as to children, and the total ticket revenue were $7,250. The question is, how many of each type of ticket was sold? So again, the best way to do this is to start by giving the missing quantities in this problem different names, and I'm going to use XYZ again. You can use ABC or any other letters or variables that you like. So X will be the number of tickets that were sold to children. The Y will be the number of tickets that were sold to seniors. And Z will be the number of tickets that were sold for general admission. And reading the first sentence in this problem, I am told that a total of 2,500 tickets were sold. So that tells me that X plus Y plus Z adds up to 2,500 tickets. So that's the translation of the first sentence. And if I continue reading, it says that the prices were $2 for the children, $3 for the seniors, and $5 for general admission. So this has nothing to do with the number of tickets. It just tells me the price of the tickets. But I'm also told that the revenue from all these tickets was 7,200. So even though it's split, I can use this information for the prices of the tickets and the total revenue to set up an equation. So I know that something was $7,250. So this was the amount of money that we made from selling all the tickets. And we sold X tickets to children, and each person had to pay $2. Then I sold Y tickets to seniors, and each one of those people had to pay $3. And finally, I sold Z tickets to the general admission people, and each one of those had to pay $5. So that is the translation of the revenue or the income that we made from selling all the tickets to the different groups of people. Finally, we are told that twice as many tickets were sold to seniors as to children. So that's going to give us our third equation. And because we're told that twice as many tickets were sold to seniors as to children, we know that the senior amount, which is what we're calling Y, is twice the children amount of tickets that were sold. So Y is equal to 2X. That is the translation of the third sentence or the third equation. So it's a good idea when you're dealing with these problems to start by organizing your system. So the way I'm going to organize is I'm going to put X first, then Y, then Z in every equation, followed by the equal sign, followed by the number. So the first two equations are basically ready to go. We don't have to change anything there, but the third equation, we'll need to put the 2x first, the y next. There is no z term, and there's nothing left when we move the 2x, so that means there's going to be 0 there. So this is the equation 1, and equation 2, and equation 3. So at this point in time, I'm going to stop here and give you a chance to pause the video and solve the system on your own and see if you can get the values of x, y, and z. I'll give you the answer on the screen in a few seconds. And the answer is x should be 750, y should be 1500 or 1500, and z should be 250.